When you design plastic parts, most of the time they will be injection molded parts. So let's take a look at how that process works. Here is a link to a nice animation of the plastic molding process. It's short, I forget, it's like 4 minutes. It's got annoying music in my opinion, so if you are like me, you might want to mute that thing, but it's got a very clear illustration of how the parts work. So it starts with a hopper, and those plastic pellets get dropped into the hopper. Now, depending on what kind of plastic material you have, sometimes there's a drying process up here. And that hopper feeds the pellets into this barrel. So this is called a barrel, and it has several parts to it. It has a screw, which will, as it turns, it draws pellets into the barrel. It's got an area up here where the melted stuff accumulates. These red rectangles are sections through heater bands, and then there's a motor here that will advance and retract. And then over here is the mold cavity itself. So the pellets drop from the hopper into the barrel, and the motor turns the screw. And this is all computer controlled, of course, CNC controlled. So it turns a specified amount, and that moves a specified amount of pellets in here. And then it stops, and the heater bands, which are electric resistance heating elements wrapped around the outside of the barrel, melt the plastic. Different plastics have different melt temperatures, so your molding company will have that all figured out, and they will use the right amount of heat and the right amount of time to melt the plastic that is in the barrel. And then, so this is a different from a different company, but here's the screw and the barrel and the melted stuff. And here at the end of the barrel is the mold with the mold cavity, and a mechanism now closes that mold cavity. It was open previously because they made another part, and the mold opened and the part fell out. So now this, usually a hydraulic cylinder, might be a toggle clamp in a small machine, closes the mold. And the barrel moves forward, the screw keeps turning and injects what is now liquid plastic from this zone through this sprue, it's called, through this nozzle area, into the mold itself. And your plastic molding company carefully analyzes and calculates how long that plastic has to sit in there at what pressure. This is from a different company, so this red stuff here is the molded part. When we see the mold come apart in a slide or two, you'll notice that these are cone-shaped bosses with cores in them. Yeah, so as I was mentioning, your molder will calculate how much pressure and how much time is required to get the highest quality part. And while this is happening, while this thing is clamped and cooling, back over here in the hopper and barrel area, the screw is turning again, and another bunch of pellets are dropping from the hopper into the barrel so that they can get melted. After the right amount of time, then the mold gets pulled apart, and here this dark red thing in here is the plastic part. So the mold gets pulled apart so that we can get the finished plastic part out of there. This round thing you see here and here, top and bottom, is called an ejector pin. So it pops out and pushes the part out of the mold. In this drawing, they're just single line drawings. What you need to know about ejecting the part, about the ejector pins, is that in most cases the plastic is still just a little bit soft because it was liquid and it's just now cooling. And so these ejector pins can leave marks on the part. They look like this. This part up here is an extreme example. Usually it's less exaggerated, but they are these round circular indentations. When you're running around in stores or out there in the world, pick up plastic parts and look at them and see if you can find where the ejector pin marks were. This matters to you as a designer because you want to think about, okay, where is it okay to have pin marks and where is it not? The mold itself is a large, really expensive affair that has all kinds of stuff going on in it, and the mold insert, which is shown here in this part, the insert can be taken out and exchanged for a different insert. So your plastic molding company will have all this big stuff put together, and when they're ready to make some parts, they'll take out an insert and put in a new insert, and the rest of the stuff stays where it is. And you can see here in this illustration there are all kinds of things. Ejector pins, but also maybe cooling systems. There might be where are we? A water line for cooling the mold, and so forth. SolidWorks has, what is it called? I've gone blank. MoldWorks or something like that. It has, as part of its package, it will calculate things about plastic molding for you, and you can buy an add-on for SolidWorks that does more sophisticated calculations. Just some more examples of the mold cavity. So if you wanted to make a smooth plastic tub, for example, here are the two halves of the mold cavity that would be inserted into the larger mold. And here is a plastic tub that's been produced and it's about to fall off. I know that you've seen Legos before. Here is a view of a Lego factory. So every one of these things is a plastic injection molding machine with conveyors. This is all robotically fed, I believe. Down in the bottom you see a retired mold. So molds, you can use them for a certain number of cycles. Might be 500,000, might be 1,000,000, might be fewer. And eventually the mold cavity just wears out and you have to retire it and make a new one. So here in the, I forget if it's the Lego Museum or the place they have in the front of their factory, you can see exhibits of these things so you can see what the cavities look like. And here is their mold ejecting some Lego bricks. Here are plastic picnic spoons. In really inexpensive parts, it's common to make a multi-cavity mold so you can make many spoons or beverage cups or whatever it is at once. These molds, by the way, cycle really fast. These spoons are cheap, so we gotta go really fast and make a bunch of them. So these molds just go back and forth, back and forth. That whole molding cycle takes only a few seconds, and then another set of spoons get squirted in there. And these mold cavities have to be refinished every so often because these need to be smooth and they get worn. When the plastic gets squirted into the mold cavity, there are several pathways for the melted plastic that the plastic goes through. So from the barrel, the nozzle at the end of the barrel, the plastic first goes into a sprue. The sprue is this main feeder thing. So here's one and here's one. Then from the sprue, it's distributed into runners, and these are branch, whatever you call them, branch flow channels. Those are runners. And if you've ever bought a plastic toy or a plastic model like of a car that you assemble yourself, you've seen these things, I'm sure. At least runners. if not sprues. And then the parts are attached to these runners, and where the plastic goes from the runner into the actual part cavity itself is called a gate. There's the gate. Here's the runner. There's the gate. And as a designer, what you need to know is that, I'm going to go past this one. Gates sometimes leave little visible bumpy places on the plastic part. So not only do you get marks from ejector pins, you also get marks from the gates, possibly. So as a designer, you need to plan ahead and think, is there a place on your part where you really need it to be smooth? And is there a place on your part where nobody's going to see it and it would be fine to have ejector pins and gates? And then you will talk with your plastic molder, your molding company. In my case, it was usually R&D Plastics in Hillsboro because they're so expert. So you talk with them and you say, and you write on your drawing, this area must be kept free of mold marks. And maybe you point to another area on your part and you say, ejector pin marks acceptable here. And you'll work that out with your molder, and then your molder will work that out with your mold maker. So there's the plastic molding process itself.